All right. So to mend all that, we have Professor Tanya Berger-Wolf here, and she's going to present an amazing talk about AI and humans combating extinction together, and more related to wildlife and the challenges we are seeing there. And I have known Tanya for a bit, but she is a professor in at least 3 departments at Ohio State, and she leads a lot of these efforts in AI and imageomics, and it's my pleasure to have. And thank you for coming.
Thank you, Suren, and thank you everyone for being patient, especially early in the morning. Hopefully, there are lots of great visuals. So even if you want to space out and just look at pictures of amazing animals and nature, you're still good. So a lot of the work that I'm going to present today is part of my research, including the newly founded Imageomics Institute, founded by National Science Foundation, and a lot of work and effort that I'm part of in AI for biodiversity conservation in different contexts, as well as the nonprofit that creates AI for wildlife conservation solutions, WildMe. So I'm co-founder and director of that, and it's part of a growing number of tech nonprofits that create technology for wildlife conservation, or actually for conservation more broadly. So with that, I'm going to start on a sad note. You probably have seen these reports. You may have seen these reports over the last many years that tell us that we're losing biodiversity at an unprecedented rate. In fact, the current state of affairs has been termed the 6th extinction. The title here, so these are reports that are compiled by UN, and this particular one says that 1 million species face extinction. So 1 million, is it a lot or a little? How many species of animals, plants, and fungi, of non-bacterial organisms are out there, do you think? Just throw a number. 100 million? Up, down? 30 million? 1 billion? Okay. So the shocking thing is that they're estimated about on the order of 10 million. So 1 million is about 10%. And in fact, majority are probably in the ocean of those that are facing extinction. So it's a shockingly large number. And if we look where biodiversity loss is the highest, it is also where the biodiversity is the highest, right? So there's a very strong, so where we have the highest biodiversity, that's where we're losing most of it at a higher rate. The problem is that we don't actually know what we're losing and how fast. The International Unit for Conservation of Nature Red List, which is the official conservation international organization that tracks the biodiversity of the world, they're termed the barometer of life. And so this is the organization, when we say that the species are endangered or facing extinction, it's because the Species Commission for that species at IUCN Red List met, and according to some metrics, determined that the species are endangered. And so the 160,000 or so out of 9 million species that they're tracking, about 20,000, actually more than 20,000, their conservation status is data deficient, meaning there are no metrics, no data to determine anything, to say anything, even make a guess. Of the remaining more than 60,000, in fact, more than 66,000, their population trend is unknown. So this is more than half of the species that they're tracking. They're either data deficient or the population trend is unknown, meaning they're not sampled, not assessed frequently enough. And these are not obscure species. These are species like orcas, killer whales. They're data deficient. The largest dolphin on Earth. The one that we're hearing stories now that they're playing with the fishermen boats in Spain. These are the ones where we have no data to say anything enough about them. Polar bears, iconic conservation species, their population trend is unknown. And it goes on and on and on. So we have the technology today to fill the gap. How do we fill this gap, this data gap? In fact, there are reports that are saying that biodiversity has a data problem. Because we can't make decisions without data. We don't know what we're losing without data. We don't know whether our policies are working without data. How do we get data? So there's a variety of sensors today that can help fill that data gap, from satellites that do remote sensing about habitats to drones and other autonomous vehicles underwater, on the ground, or in the air, on-body sensors, the in-situ sensors such as autonomous camera traps, so automatically triggered camera traps, motion triggered, or acoustic sensors, as well as these guys, right? These devices that take pictures at an unprecedented rates. We photograph everything, and a lot of it is living organisms. So how many of you have taken a picture of a living organism in the last week? Humans do count as living organisms. Just a reminder. So a good number. And if we, globally in the world, people take pictures all the time, so we can tap into that source. So this is a figure from last year's survey on machine learning for nature conservation, paper in Nature that co-authored by many colleagues and myself. So great, we have the technology, let's go. So there must be tons of data points out there for biodiversity of the world. So that is a reminder, these are the hot spots of biodiversity. The redder, the higher the biodiversity, meaning the composition of species. That's the loss. And the global GBIF, the authoritative sort of biodiversity data holder, the global biodiversity information facility. Notice the difference between where they have data versus where the highest biodiversity is, right? It's almost complementary. And it's not unique to GBIF. iNaturalist, the platform, the online platform where people can just upload observations of nature with a fantastic app. You go out, you see something living, whether a plant or fungus, and you can take a picture, upload it, will run even machine learning to determine the species. Again, same thing. They have probably the highest collection, more than 130 million observations of 500,000 species. But they're concentrated not where biodiversity is the highest. Same thing for eBird, another citizen science platform for bird observations. The entire African continent is almost not there. So we still have a data problem. And by far the largest source of information about anything today, as you notice, like I asked who's taken a picture, are images coming from all of these sensor modalities and these devices, even when we don't realize that we're taking pictures of nature. Even when we think we're taking a picture of a living human organism, there's quite often nature in the background, right? So we even have the methodology today to take advantage of these images, of these data modalities and others, but particularly of images, and extract information about them. We have off-the-shelf, essentially, methods today for detection, as in finding, do we have an object of interest, putting a bounding box around it, classifying species, as in gravy zebra, African buffalo, in this case, and doing even pose estimation, the stick figure thing that allows us to then go to behavior, or background reconstruction for habitat, environmental reconstruction, and even individual ID. I'll tell you a little bit more about it. So we have, one would say, we're done, right? Like, this is it. We're now can take and, but one, we have to enable more data from the places where we don't have right now, which is the highest biodiversity. And the problem is also that the majority of these machine learning AI methods are also produced in places that are, again, not the highest biodiversity and the highest biodiversity loss places in the world. So they're produced in total absence of the context of biodiversity. They're not engaging people who need these methods, and they're not at all deployed in these places because AI is expensive. AI is expensive in terms of labor, in terms of resources, every aspect of the resources that it has, right? So there is still a huge gap. In fact, so I was part of the Global Partnership on AI, which is an advisory global 29 countries and growing body to OECD and governments, producing this AI reports on where the opportunities, challenges, and gaps are. And so I was part of the AI for Biodiversity and Artificial Intelligence report. And sort of the quick summary, what are the opportunities and challenges are data, not surprisingly, in biodiversity, outreach. So outreach and engagement, we have to prioritize the outreach to local communities, bringing them in, being part of the creation of these solutions, not sort of being those for whom these solutions are created. Funding, there's almost no funding for biodiversity. I can go on for a while about it. And tools and metrics, so that is creating and capacity building. So we need to bring not only here's a method, the colonial approach where we create something in some, in Portland, Oregon, bring it to the take the data from the from Africa, process it somewhere in US, spit out the solutions, and now you have to put out the resources, the money, land, people have to do something based on that black box thing that we used on your data that we took from you. There has to be a different model to all of this. We have to build capacity where it's needed. And so how do we, because right now there is no trust in any of these solutions, even if they exist, which they're few. So how do we engender trust? Sort of to reframe the recommendations of AI and biodiversity, GPI's AI and biodiversity report is it has to be an inclusive and collaborative partnerships with the local community and the stakeholders. There has to be transparency and accountability. I'll say a little bit more about it in a second. And then AI safety. And part of AI safety and doing no harm, it also includes environmental harm. So we increasingly talk about the fact that AI is expensive, not only in terms of sort of the money that it takes to build a system with multiple GPUs. So here's a statistic, by the way. All of the supercomputing centers of US together, the total number of GPUs in all of the supercomputing centers in the country, academic ones, are still fewer, but comparable, just to the number of GPUs that Microsoft gave towards OpenAI. Like this is a shocking disparity, right? If we start, certainly there is a huge gap between academic resourcing, even within this country, right? And certainly the environmental cost, this is from the AI Index report this past year. So this is the CO2 emissions. If you can't see, I'm gonna point out that the first one is the flight from New York to San Francisco. The car thing, the pink car thing, is the emissions of a typical average lifetime of a car with the gasoline car, right? Not the electric car. The last one is training, the emissions associated with training GPT-3. It's 10 times more. This is like shocking. GPT-4 was actually a little bit more, not exponentially, thankfully. But I mean, this is what it takes to train these models, that a majority of them are used for what? And so do we really need to contribute, to take the resources collectively from the rest of the world, including the rare metals that go into the hardware, to what? Produce better resumes or homework solutions, right? Or product recommendations. So, or improve an accuracy of something from 96.5 to 98.3, right? So this is also a consideration. So here's a version of how we engender trust and how we use AI judiciously for conservation. So this particular version is part of the platform Wildbook, which is a project of WildMe, the nonprofit. So it started with research, and then we realized just that it needs to be in the hands of those who can use it, need to use it. So how do we go from these millions of images, of photographs that are coming from all of these sources to something that is useful for conservation? So the platform, we built a platform that can take all of these millions of images, find all the ones that contain animals using all of these machine learning methods that I outlined, find all the animals in them. So put a bounding box not only around that big mama elephant, but a baby calf hiding behind it. And not only classify species, as in savanna elephant, humpback whale, gravy zebra, and hawksbill turtle, but identify down to individual animal, as in Zippy the zebra, and Joe the giraffe, Terry the turtle, and Willie the whale, using the unique biometric, unique spots, stripes, wrinkles, notches that animals have, including the shape of a whale's fluke or the dorsal fin of a dolphin. All of us have unique biometric identifiers. Every animal, even when we don't realize it. Right, the shape of our ear, the iris of our eyes, the fingerprints on our fingers, the wrinkled patterns on our palm, all of it is unique. We're special, and so are every single animal. And so together with the information on when and where the images were taken and who it is, we can really start tracking, counting, finding the population dynamic, identifying births and deaths, as well as the social network of animals purely from images. So this is an example of a Wildbook page from a Wildbook for cetaceans, that's whales and dolphins. And this is Pinchy, the most cited individual in that Wildbook. She is a sperm whale, hangs out around Dominica in the Caribbean. I would too. Like, she has the right idea, right? She's been cited more than 600 times. These are social species, so you can see the social network over there, who she hangs out with. She loves having her picture taken. Notice also that Wildbook is a relatively new platform. It went live in 2014, and yet now there's data from 1995. Because the moment a platform like this exists, people can start uploading data that used to be dark until this point, right? So they're historic data. So today, just Flukebook has almost 3 million images coming from a variety of sources. Together, almost 370,000 sightings of 73591 uniquely identified individual whales and dolphins. So guess who are among the newest species in that Wildbook? This is the quiz time. Orcas, killer whales, the ones that are data deficient in IUCN Red List. Last year, we put up, the Wildbook exists, the platform exists. So the Bureau of Ocean and Energy Management started putting their historic data on orcas. Immediately, everybody else, oh, we have data too, started adding to it. So we're hoping that this year, the Species Commission for IUCN Red List will, for killer whales, will meet to determine their conservation status. There will be enough data now to run it through the metrics. That's an amazing thing, right? There's not even additional data collection. So they're already, we can fill a little bit of that data gap with the data that are already there, plus a lot of machine learning enabled by a lot of already existing hardware and technology, right? So but it's not enough, right? There's still more, and particularly in the oceans. So, you know, how do you use a chat bot for good? This is so we built an intelligent agent that scours the publicly posted images, in this case videos, on social media, finds the ones that contain animals of the appropriate species. And in fact, we did not train, explicitly did not train or fine-tune GPT, because you don't need it. You can get away with much, 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 much simpler technology than that. So this is the trade-off, right? When do you need this state-of-the-art technology versus you can get away with something, with keyword search, which in this case you actually can't. To find, in this case, whale shark, find when and where. So when there is not enough information, the chatbot does engage. Like, hey, when did you see this whale shark? And people start saying, oh, last July, my family and I went on vacation in Cancun. We had a fantastic time, saw some, oh, wait, you're an AI. But yeah, July 2017. Thank you very much. So, you know, we then add information to the appropriate Wildbook, in this case, Shark Book, and post in the comments, hey, 2 minutes, 46 seconds, we saw this whale shark. Here's everything we know about it. And people respond, like, inevitably, even when they do know the AI, this is like, oh my God, this is amazing, because they realize that their vacation in Cancun and they're taking pictures of these amazing animals can actually contribute to science and conservation. They didn't realize it. And the most common response is like, how can I help? Right? Because they suddenly connected. We've connected, AI has connected a human to a conservation source, right? They connected them to an animal, to a particular animal. And through that connection, they now have been nudged to contribute a little bit more, to do something a little bit more. They now have a personal connection. AI, in this case, is not removing the human from this, not distancing a human from nature, but bringing them a little bit closer through that connection to an individual, through telling a story, essentially. At the bottom of each page of Wildbook, we also post all the organizations and individuals who have contributed data to that specific individual, again, in an intentional effort to connect not only people to data, but people to each other, because these are global species. There is not one organization, not one project that has information even about one individual whale shark. It's only by putting all that information together that we can build a picture of this global animal. And that takes not only intentional effort, that takes a lot of sort of technology behind it, right, to do this, but to make it in a way where people feel the connection and don't think about the AI and the technology that goes behind it. So today, Shark Book has almost 20,000 uniquely identified sharks reported by, from the sightings reported by more than 10,000 citizen scientists who directly contribute to the platform. the organizations, conservation and organizations and scientific projects, as well as one very intelligent bot that contributes almost half of these sightings. And they're distinct from all the other ones. In fact, we've tested that. So this is like fantastic, because this is really data that would otherwise not have been at all seen, at all reported. Right? And so, in fact, the IUCN Red List entry for whale sharks was updated in 2016 already, based on data from Sharkbook, and the global population estimate was updated. Based on those data, the conservation status of whale sharks went from vulnerable to endangered, and the population trend from stable to decreasing, not because the species are doing worse, but because we had the right data to assess the current status in a much more accurate way, right? Without the huge uncertainty bounds around each estimate that allowed to really say, no, the population is declining, and the population and the species status is endangered. And that triggers a lot of policy change. It triggers resources allocation in a very different way for this species. So that is not that one species data point, right, has global consequences. The most comprehensive study on biodiversity, on the biology of the species, also was published from data using data from Wildbook and co-authored by 37 authors who didn't meet prior to meeting at the bottom of that page of here's who contributed to this particular individual. This is the paper I'm most proud of in my career. I'm not the co-author on this paper, because the technology that we built, the platform that we put out there, enabled understanding of the seasonality of migration patterns, enabled the understanding the population dynamic of this species, right? Without that, it wouldn't have been possible. The assessment, it changed the protocol for assessing the conservation status of the species. The follow-up paper. We have platforms we have platforms today for more than 70 species, ranging from whales and dolphins and sharks to zebras and jaguars and skunks. And one of my favorite are the weedy and leafy sea dragons. These are relatives of seahorses, weird animals, look like aliens. Amazing indicators of the health of the coral reefs. Oh, right, okay. The same technology that enables Wildbook with the same GPUs and the same cloud resources also enabled the first ever full census of the endangered gravy zebra in Kenya in 2016, using photographs from ordinary people just driving around the country for 2 days, taking pictures of every zebra that they saw. These are not the zebras you're thinking of. I know what you're thinking. You're thinking, Serengeti, thousands of zebras running through the savannas, right? Those are not endangered. Those are common zebras. There's thousands and thousands of them just in one population. These zebras have Mickey Mouse ears, and you see them mostly in the zoos. You are welcome to go to the Columbus Zoo. You'll see gravy zebras. These are endangered. There's total in the entire world about 3,000 of them. That's it. 95% of them are in Kenya, but there are a few hundred in Ethiopia. And so in January 2016, for 2 days, hundreds of people were driving around the country taking pictures of zebras. This is everybody from school kids to local tribal chiefs and park rangers and tourists with telephoto cameras, to US ambassador to Kenya at the time, Bob Godek. who took together more than 40,000 images of this amazing animal. And so using the same machine learning and computer vision, identified all the individual animals in those pictures and determined using very simple piece of statistical modeling that there is 2352 plus minus 72 animals in this population, which was the most accurate entire population estimate to date. So much so that Kenya Wildlife Service went from, this is not how we count zebras, to, wait, this is exactly how we count zebras. And now you're on the hook every 2 years. So we did it again in 2018. And to make sure that it is not, and notice if you're paying attention, the population size has gone up. To make sure that this is not the exercise where we take data, analyze it somewhere in Portland, spit out a number, and then tell Kenyans this is what you need to do now in terms of policy and conservation. We made sure that it was completely local effort, which takes a lot of work. That aspect of engaging local communities, of building capacity, of ensuring that it is the local policy with the local knowledge that is in play here. We got donations of GPS-enabled cameras. We came up with an amazing old school, new school protocol to ensure that everybody who had a camera of any kind, with or without GPS, could participate and sync their camera to the one with the GPS, so we knew where the pictures were taken. Using this QR code, and in every car they had this starting thing, 3, 2, 1. Everybody takes a picture at the same time, and then we sync the cameras. There was a booklet produced and explaining the whole event with not only what people are going to do, what the technology behind it, how it's enabled, what's going to happen to their pictures, what's going to happen to data, how Kenya Wildlife Service is going to determine the population size, how to take good pictures, the competition of who takes best pictures, most pictures. There's this whole social media campaign done completely by local nonprofit organizations. And we did training to everybody in the entire region, explaining sort of training for this event. From Kenya Wildlife Rangers, notice you can't quite see them. You see a little bit of these AR-15s because this is what's needed today to protect animals in the wild. We did this in English, in Swahili, in Samburu, Maasai, Northern Maasai, to make sure that with the help, obviously. I don't speak enough Swahili, and I definitely do not speak Samburu. So it was translated to make sure that everybody could participate. We did training on how to use Wildbook for conservation organizations in the countries. They all provided sort of their representatives. Notice, this is a great T-shirt, but it also is a huge problem of there's no Wi-Fi. It's completely uninstrumented environments. There are no resources. There is no compute. We worked with Google and Microsoft to open up, like everything is sneaker internet, right? We downloaded all the SD cards at the end and had to take them to a place where there was a landline, not good enough, then had to take it to Nairobi, where Microsoft opened up their dedicated upload, and sort of simultaneously Google gave us like big good chunk of space on Google Drive to allow us to upload all the images and then upload up the data to the cloud. And Microsoft allocated Nairobi Azure allocation, dedicated Nairobi Azure allocation for this, so that the analysis could be done. And then based on that, Kenya Wildlife Service changed their policy, and all the governors of the counties where there are gravy zebras, together with the Kenya Wildlife Service, came with this proclamation for the new policy to manage this endangered species, which does put money, people, resources, land towards it. Assistant Director of Kenya Wildlife Service said, this shows the power of citizen science and machine learning for conservation. This is the first time that the words he used machine learning in a sentence, ever. Like he said so. I cried. The IUCN entry was also changed, for gray zebra was also changed based on that data. So this is a great story. We could stop here, right? Technology enables conservation at scale. In fact, not only Kenya Wildlife Service now trusts AI and machine learning, the tagline for this event is Kenyans powering conservation, and we're going to do another training in November for the new updated Wildbook, so that really, truly, the whole event, all of it can be done locally, right? To build that capacity. I'm going to speak at Applied Machine Learning Conference in Nairobi in February. There have been 2 big machine learning events, like big conferences. iClear was in Rwanda. So this is like about the capacity building, right, on the continent in this case. It is still uninstrumented. We were filming the giraffe surveys in July, in August, sorry, July. We were just filming sort of how they work and training. It was maddeningly slow, the upload. There was just not enough bandwidth, and there is nothing. So it's all cloud-based, right? We think today cloud-based is great. We can just upload to the cloud, do all the processing there, done. Just doesn't work. There is nothing that could happen in the amount of time that we were filming, in the amount of time that they then had to happen, in the amount that they had to do the survey, right? So they send out all the park rangers, all the local community members to take pictures of giraffes, and we could not get any results on the spot. In fact, it takes months, because it's all still sneaker internet, because it all still, has to be taken somewhere. The other challenge is that what's gold for science and conservation managers, these images, right, that fill the data gap, are also, unfortunately, beacons for wildlife criminals. Geotagged images of animals can attract poachers to the location within hours. Right, so you'll see these signs: do not geotag your images, do not post them on social media. People don't realize that this device quite often geotags automatically, adds location to the images. They don't realize that when they're sending, posting on Facebook, that their policy is public or enough of the world that these images can become useful. And so we, a while ago already, wrote this the white paper on privacy for tigers. It's still an unsolved, unfortunately, problem of how much data is being leaked, but at least now people are starting to work on it. The other problem, the other challenge is that there are huge biases in the process, right? There's the true population, let's say, of zebras or other animals. Then there's the being at the right place at the right time to even see the animals. It doesn't matter what device you're using to get this data. And so this is particularly important for remote locations. We know very little about the oceans. We know very little about the polar ecosystems. We know very little about cryptic animals, the ones that are during the night or really good at hiding. Rare species at the edge of their range and habitats, and so on and so forth. Then deciding to take a picture, whether it's automatic triggered, being the motion camera, actually being triggered, or the tourists deciding, oh, this is a cute zebra, let me take a picture of it. And then if we're talking about social media, which social media, where are you going to post it? the APIs that they give you to collect those data, and then the model that you're going to use to analyze. But all we actually care in the end is the error in this estimate. So this is part of my research is really how do you get unbiased estimates from all of this biased data, where the biases are stack up. And the other part of my research is imageomics. So we started, so interpretable AI, particularly in the context of biology. So we can go beyond saying this is this particular, this is this species of a bird, but this is this species of a bird because has yellow belly, black behind the beak, and it wobbles when it walks, right? So these are biological traits. And so funded by the National Science Foundation almost 2 years ago, the Imageomics Institute, the goal of Imageomics Institute is to establish this new field that makes traits and phenotypes of animals and other organisms, animals, plants, and even cells. This is so to be able to say this is cancer cell because it has these traits, it has this phenotype, right? To make them computable from images, to mobilize traits from images. In the process, really understanding how we can make AI interpretable, if not explainable. So I hopefully over the last 40 minutes, you had a taste of how AI and humans can enable science conservation and public engagement by bringing communities together and working in partnership to provide solutions that people do trust. And I would like to thank a large number of people, including the entire team of Wildbook, the team of the community of Imageomics, and many supporters of this effort, as well as the thousands and thousands of people who not only throughout the world, who not only take images, annotate them, test our algorithms, but really truly do the work that it takes to protect the biodiversity of the world. Thank you.
Thoughtful-looking and more world-helping talk. So we have a couple of questions we can take now.
Thank you for the work that you do, and thanks for sharing it with us. I have a quick remark and a question. So your data on the CO2 emissions, I'm not sure how many people are aware, but apparently Bitcoin mining, takes 1% of total energy consumption in the world, which is just crazy. So this slide that you had on bias is really interesting, and I'm just curious if there's another concern that potentially is on the horizon for you, and that is bad actors and viruses in data, in the sense that somebody could, they really like the whale Pinchy, and they decide to create a bunch of AI imagery about Pinchy in the San Francisco Bay Area and upload that. And I'm just kind of curious if that's something you're facing or believe you will face.
Right. So thank you for both the comment about Bitcoin. Yes, in general. So all aspects, even that CO2 emissions, does not take into account running the services, the cloud services, right? In general, it's just the specifically the energy that it takes to train the models, purely for that. So there's no background kind of startup cost for any of that are included in this. It doesn't talk about water, for example. So water is a huge resource, right? That is required by any HPC or a center or a data center. It's huge, including the UNSECO factory that's going to be built here. So and it's not AI is the growing consumer of a lot of the resources. Bitcoin mining it contributes already 1%. AI is estimated to be contributing by the end. Sorry, I don't remember the number, but it is already overtaking the Bitcoin mining, and it's sort of already single digit of the global energy consumption, and it's going to just grow. To the generative AI used in conservation to generate images of pinchy or other animals. So, yes, it is certainly a possibility, and then the point is it going to skew the population numbers, or is it going to change our understanding of biodiversity? So the platform as it is right now, it's curated, and all the so curated by biologists, so you cannot generate pinching in San Francisco because pinching doesn't make Dominica, sorry. Right, and you know, so humans are still, we're not replacing humans with any of this. In fact, the way we measure the utility of the system is not people asking, so what's the accuracy of your AI algorithms? That's the wrong question. Because it's not about how accurately you can identify whales from really highly, the benchmark data set. It has nothing to do with the reality of what's going on, and it's not the goal. The goal is to go from a system which is completely human curated. Like every Wildbook that we build, every system that we have today for biodiversity monitoring and conservation already exists, but it's done completely by humans, right? And so it's the trade-off between the human effort versus, how much can we do, how much can we automate, and how much of the data gap can we fill? How much of the metrics of IUCN Red List can we enable, right? How much of the assessment? So we don't measure the accuracy in terms of the accuracy of one specific algorithm of one data set because it's immediately deployed on new data sets. Right? We have we're tracking for all wildbooks across the world. Every month we add a number of new species. So immediately people are applying either existing or a growing number of algorithms. The entire catalog of North American whales, the entire government catalog from NOAA, so Department of Interior, of North American whales is now on Wildbook platform, including historic data. So we can never use that as benchmark data set, right? Because it's not, we always say we're open source, open collaboration, protected data, because it's not our data, and it's the government's data, and they're not going to protect the species. But it's also, it's irrelevant. Is it useful in this trade-off? How much of AI in computer vision, how much of the technology versus human effort, to reduce human effort, to enable doing the tasks that humans need to be able to do? That's the metric, right? And so it's the curation, the accuracy of curation of the entire data set, of the entire population in this case, or entire species. And so the accuracy of curation, not the accuracy of the algorithm using the trade-off. So that metric, I can tell you that we've reduced the human effort down to about 5% of the original, while expanding and the amount of data that are coming in, without sacrificing the accuracy of curation. So the numbers that are coming out. Will generative AI play a role in this? For sure. In fact, training algorithms on rare species, on these cryptic species, this is where generative AI can play a role for producing simulated data and algorithms. We think that is much more so than we hope. I mean, and that's in the curation effort that's going in that it's more than the bad actors producing fake tigers in Africa.
Has the internet by satellite changed the ability to gather data in Project Kuiper and start?
Right. So there is some internet by satellite. So in fact, the white space internet started in Kenya. They tried a lot of technology. So Mawingu is a company that Mawingu Cloud is a company that started in Kenya, and now it's throughout the world. In fact, similar technology is happening here. That is just providing some satellite internet. It's super slow. It's, images are super bandwidth hungry. And so part of it, and part of ICICO and our institute that is here, led by Ohio State, to provide the set infrastructure and AI-enabled set infrastructure for AI, is how much of the learning can be actually pushed to the edge. Okay? How much of processing can we push to the extreme edge and do on devices, on camera, before actually collecting images. So judiciously collecting compressed images, small images, reduced resolution images, because the bandwidth right now is a huge bottleneck, even with satellite internet.
Yeah, we have to take a little break. Maybe you can. Thank you so much. Yeah, thank you for this talk. And